Bonjour and welcome to 5-5 of Pre-Calculus, Multiple Angle and Product to Sum Formulas. This section is just chock full of formulas, as you can see on the formula sheet. Today we're just going to get through the first bullet point here, use multiple angle formulas to rewrite and evaluate trig functions. In later videos, we will see the power reduction formulas, the half angle formulas, the product to sum formulas, the sum to product formulas. And we'll use these to rewrite and evaluate trig expressions. We can also, of course, model and solve real life problems using mathematics. There is nothing that math cannot do. And here we go. In this section, you will study four categories of trig identities. The first category involves functions of multiple angles, like the sine of 2x or the cos of 8y. The second category involves squares of trig functions, like sine squared or cos squared or tan squared. The third categories are functions of half angles. Notice here that's like the sine of some angle u divided by 2. The divided by 2 is what makes it a half angle. We're cutting that angle in half. The last fourth category involves the products of trig functions, like the sine of angle u and the cos of angle v, and those are multiplied together. You should learn the double angle formulas because they're used often in trig and calc. There are a couple times when these do pop up in calc. Of course, we have a little refresher on those just to, bring those back into the front of our brains. So let's check these formulas out. If you have sine of a double angle, there's only one option to replace this with. Notice when this angle 2 times u hops in here, the 2 disappears. The double angle is reduced down to a single angle, sine of u, cos of u multiplied, and there's a 2 out front. Same thing on tan of the double angle. When that double angle jumps in, it turns into 1u, not a 2u. So we're using those double angle formulas to get these down to smaller angles. And that's 2 tan up top, and our denominator is 1 minus tan squared. So for sine and tan, there's only one option. When you take this out of the equation, you have to replace it with this. Same with tan. But with cos, we have options. I'm just good for ease of convenience. Option 1 has cos squareds and sine squareds in it. And again, notice the angles are down to just u. If we only want coses, we could use option 2. 2 cos squared minus 1. That would, we would take this sign and replace it with 1 minus cos squared, and then distribute the negative and collect like terms. Or if we replace this cos squared with 1 minus sine squared and combine terms, we get option number 3. 1 minus 2 sine squared. So depending on what else is going on in the problem, you might want to use option 1 or option 2 or option 3. I think we'll see that making that choice in one of our examples coming up. But example 1 is a nice, easy, slow pitch right across the plate. Solve a multiple angle equation. We want to solve this. It's already set equal to 0 for us, but the first thing I notice is we have cos of x and the sine of a double. So that's apples and oranges. We can't do much with it in its current state. So we are going to replace that sine of the double with something. I'm going to copy the 2 cos x first, plus sine of the double. There's only one thing on the formula sheet to replace that with. That is 2 sine x cos x. Now every angle is just x, apples and apples comparison. Ooh, and this is equal to 0. Now notice on each side of the plus sign we have a 2 cos and a 2 cos. So let's factor out that 2 cos x. And what's that going to leave us in the grouping symbols? Well, this was factored out entirely, so that's a 1 plus, and all we have left there is a sine x. And that is equal to 0. Okay, so we were able to factor it. It's set equal to 0. I think you know what's coming next. Let's set each factor to 0. 2 cos x equals 0. We can divide by 2. And then we look at our unit circle if we do not have it memorized. And we're going to get x equals pi over 2 plus 2 pi n. And x equals 3 pi over 2 plus 2 pi n. Now, you might be yelling at your computer, we can combine those. We can combine those into one answer. We'll do that in just a second. Let's jump over here to this one. 1 plus sine x equals 0. So that means sine x is -1. And sine values are y values. Where is the y value -1 on the circle? That only happens at one spot, down at the bottom. 3 pi over 2 is our angle, plus 2 pi n. Now, I didn't combine the blue angles over here on the left because now I think it's easier to see that this is just overlap. Our second factor is overlapping with this one down here in the blue angles. So when we combine these two blue angles together, we're just going to get x equals pi over 2 plus pi n. 1 pi n. So, these were sort of combined together and then they were rolled into the first one. X equals pi over 2 plus pi n. There we go. All right, good problem. Example 2. Ooh, now we're going to set up a triangle on this one. The directions. Use the conditions below to find the sine of 2x and the cos of 2x and the tan of 2 or x theta. We got double angles here, and the conditions they gave us to get started are cos of theta and theta is here. So they gave us single theta and they want us to find the double stuff. Well, we're going to set up a triangle and let's figure out what quadrant we're in. 3/2 to 2 pi. That looks like quadrant 4. So I'm going to draw a quadrant or a Cartesian plane accentuating quadrant 4. We go from the origin out into the quadrant and back to the x-axis. So there is our triangle. Angle theta will be at the origin, as it should be. And cosine is 5/13 or adjacent 5 over hypotenuse 13. Now you could do Pythagorean theorem, 5 squared plus b squared equals 13 squared, or you might recognize a 5, 12, 13. And notice from the orientation of the triangle, we are now going down below the x-axis. That means the 12 is going to be a -12. Okay, the triangle's set up. We should have no problem answering the 3 questions that they're looking for. The sine of 2 theta is equal to 2 sine theta cos theta. So now we can just start plugging and chugging. That 2, I'm going to write it as 2 over 1. And cos, let's see here, they gave us cos. Cos is 5 over 13, so this cos is 5 over 13. And now the sine of theta, that's where we're going to go to the triangle. Over to the triangle, I'm at angle theta's perspective. Sine is opposite over hypotenuse, -12 over 13. Okay, let's multiply straight across. 2 times 5 is 10, times -12 is -120. Downstairs, 13 times 13 is 169. So there is the sine of the double angle. We set up our triangle, and then we use the formula to get there. Nice. All right, cos of 2 theta. Remember, cos has options, option 1, 2, 3. You can use any of these, absolutely fine. I usually stick to option 2 because you're just going to find cos and you're going to square it, and you're going to double it and -1. At least for me, there are less chances of mistakes if I use option 2, but you can use any of the options that you want. So this is going to be 2 cos squared theta -1. Now, when dealing with exponents, remember the cos squared of theta, that's exactly the same thing as the cos of theta quantity squared. Might be easier to see that we're going to plug the cos of theta in those parentheses and then square it, and then multiply by 2, and then finally subtract 1. So 2 is 2 over 1. Cos, again, is what they gave us to get this problem started. Cos is 5/13. And let me just do this. There we go. So if we square, 5 squared is 25, times 2 is 50, over 13, the denominator squared is 169. And I'm going to write the minus 1 as minus 169 over 169, because that's the same thing as 1. And then if we subtract our numerators, 50 minus 169 is negative 119 over our common denominator, 169. So there is sine and cos. And I think, well, move that up there. I need a little more room because I don't want to erase this. I'll just shrink it up a little bit. I guess that'll work. There we go. Put it over, yeah. Now tangent, there's only one formula for tan. The tan of the double angle, 2 theta, is 2 tan theta over 1 minus tan squared theta. Tan squared theta equals. So just in the numerator, here's my sort of division line, the double line there. We've got a 2. I'm going to write it as 2 over 1. And then tangent is opposite over adjacent. Opposite is negative 12. Adjacent is 5. Negative 12 over 5. And now I'm going to switch to blue ink for this 1 minus tan squared. That's going to be 1 minus tan squared. And we already figured out that tangent is that negative 12 fifths. All right. So from here, it's just some arithmetic, not even really any algebra. Numerator's not too bad. 2 times negative 12 is negative 24 fifths. Now, careful in the denominator, we've got 1 minus, and I'm going to write that as 25 25ths. Minus, when we square it, this negative will get squared away. So that's going to be 144 over 25. Okay. Now, if we do that subtraction, 24 minus 144, that is negative 119 over 25. And that is under this negative 24 fifths. So we've got one fraction divided by another fraction. We know what's going to happen now. We're going to flip and multiply. Actually, before we even flip, let's get rid of those negatives. Negative numerator, negative denominator, those are going to cancel. Oop, get out of the way. Get out of the way. Bring this up and flip it. So now it's 25 over 119. And before we multiply, we can factor down by a 5. So that 25 will turn into a 5, and the 5 turns into a 1. 5 times 24 is 120 over 119. And that is the tan of the double angle 2 theta, negative 120 over 119. Now, while I was showing you the formula there for tangent, you might have been screaming at your computer, why don't you just do tan is sine divided by cos? And I wanted to show you the formula first. Usually, though, the easier way to go, since we already found sine and cos up here, let me bring these back down over here. Sine is the red one, and cos is down here in the black ink. So just bring it up and flip and multiply. Sine divided by cos, that's going to be 169 over negative 119. The negatives cancel, the 169s cancel, and what we're left with is 120 over 119. And how did I have a negative down here? We did say those negatives canceled. That is definitely positive. All right. I think it's time for some practice problems for you. Yeah, so pause the video and try the problems. Fire it back up to see if your answers match mine. Now on this first one, we are dealing with the cos of the double angle. And cosine has options 1, 2, 3. 1, 2, 3. So again, let's look at the rest of the problem to see which one of these might be most useful. So here's our cos of the double, and the other term in our equation is another cos. So we've got a cos, we might want to stick with coses. So that might mean option 2. If we use option 1, we'll have a cos squared, but then we're bringing in some sines. If we use option 3, we only have, sines. So option 2 looks like the one to use, 2 cos squared minus 1. 2 cos squared x minus 1 plus, we've got another cos x just lurking there. Bring them along. And there we go. Let's write it in proper order. So we're going to put our squared term first, plus 1 cos of x, and then a minus 1 equal to 0. Now we did problems like this a few sections ago in, I think it was 5.3. So this looks like we're just going to factor and set each factor to 0. So let's see, our leading term must be 2 cos squared, and that is going to come from a 2 cos x times another cos x. The constant at the end, 1, only has 1 and 1 as its factors. We want a plus in the middle and a minus at the end. So when we multiply the outers, we want that to be a positive 2 cos. And then when we minus the inners, well, minus 1, that'll take us to the plus 1 that we're looking for. And we have it factored. Now let's see. I'll switch to red ink. And if we set this one equal to 0, to get this cos x alone, we're going to add 1 and then divide by the 2. So cos is a half. And that happens at 2 spots. X equals pi over 3. That was supposed to be a 3. And x equals 5 pi over 3. Quadrants 1 and 4 where cos is positive. We are not on a restricted interval, so we can give this the infinitely many more solutions, plus 2 pi n. And if we look on the circle, they are not directly across from each other. We cannot combine them into one answer. Next factor, cos x plus 1, set it equal to 0. You're going to get cos of x equals negative 1. Cosine values are x values. Where do we go on the unit circle to find an x value negative 1? That's all the way over to the left at pi radians. Pi radians is one answer, but then we'll have infinitely many more if we add more trips around the circle. So there's our 3 solutions to our original question. Next up, we're going to set up a triangle and solve for the double angles, giving single angles as our given info. So let's see here, we're 0 to half pi. That's quadrant 1. Here's a quadrant 1. My triangle goes out from the origin and always back to the x-axis. Theta is at the origin. And sine was given. Sine is opposite over hypotenuse. Opposite 3, hypotenuse 5. And that makes this a 3, 4, 5 triangle. And everything is positive. The 4 would be positive, and we are in quadrant 1. And we know that everything is positive in quadrant 1. Okay, let's start finding our doubles. The sine of the double is equal to 2 sine theta times cos theta. So 2 is 2 over 1. Sine is what they gave us, so that sine is 3/5. And we're going to multiply that by cos. Cos is adjacent over hypotenuse, 4/5. And if we multiply straight across, we get a 12 times 2. That's a 24. Over 5 times 5 is 25. So there is the sine of our double. Put that right about here. And I think we can shrink it up a little bit. There we go. Next up, cos. Cos of the double is equal to, remember we have 3 options. I usually go to 2 cos squared minus 1. If you use the different formula, just watch through till the answer. They should be the same if everything was done correctly. So we've got 2 over 1 times cos squared. Let's put in cos. Cos is adjacent over hypotenuse. And I'm just looking ahead. When I square that denominator, it's going to be a 25. So I'm going to rewrite that 1 as 25/25. Okay, order of operations, we square this first. So that'll be a 16 times the 2 is 32. We square the denominator, 25 minus 25/25. And if we subtract, we keep our common denominator. 32 minus 25 is 7. 7/25. And I'm going to put that right about here and shrink it up a little bit. Now we've got sine and cos. We could use a formula to get tan, but tan is just sine divided by cos. That's supposed to be a 2. So sine is 24/25. We're going to divide that by cos, 7/25. Bring up that denominator and flip it. So now it's 25/7. And we can see on the diagonal, the 25's cancel. If we multiply straight across, 24/7 is our final answer for the tan of the double angle. Okay, one last example, and it's kind of a doozy. There's a little bit of work going on in it. This, of course, is going to be very, very similar to the huddle problem, our last one of the day. But first, a note here about these double angle formulas. Let me back up to the original. Again, notice when the double angle hops into the formula, it's not a double angle anymore, it's a single. So this was a 2 times something. When we bring it here, it's divided by 2. It's a single angle. Same thing here, went from a 2 to a 1. Goes from a 2 to a 1 when it hops in the formula. Now this can also be true. Let me, I guess I'll just do the sine. If we have the sine of, let me make it 10x equals, I'm going to copy the formula, 2 sine of something times the cos of something. We can do the angle or the formula on this, but when the 10x jumps in here, just like here when it got cut in half, this is going to be now a 5x, and this is going to be a 5x. Or for cos. Cos of 8x is equal to 2 cos squared of 4x minus 1. When we jump into the formula, the angle gets cut in half. This 8x got jumped in, and it got cut in half to a 4x. That's what the book is saying here. The sine of 4x, again, when it jumps in, it gets cut in half. Cos of 6, when it jumps in, the angle gets cut in half. Okay, double angle formulas. What about a triple angle formula? Why aren't those on our formula sheet? Well, if you want one, we're going to have to derive it ourselves. And the directions here say rewrite sine of the triple in terms of just sine. And when they say just sine, it could be sine, sine squared, sine cubed. The key here is the angle is 1x. We're starting at 3x. So we've got to get everything down to some form of sine, and it's going to be the angle 1x. All right, buckle up. Here we go. So we've got the sine of 3x. And we could rewrite 3x without breaking any of the laws of math. 3x is 2x plus 1x. Aha. Remember a couple sections ago we had formulas for sines of a sum? This is the sine of a sum. So the pattern there is sine cos plus cosine. Sine, cos, cos plus cos, sine. And we populate our angles. 2x goes first, x goes next. So 2x and then an x, and then we get a 2x and an x. All right, now look what we got here. We've got a sine of a double. At least it's a sine. We can reduce that down again. We've got a cos of a double. We've got some formulas for that. Let's just see how this problem develops. So I'm going to underline in blue this sine of 2x, and that's going to become a 2 sine x cos x. Now be careful. I'm going to underline here in green. We've still got this cos x. Don't lose track of that. So that's times a cos x. Plus. Now here we've got the cos of a double. Remember, we've got options 1, 2, and 3. This would be option 3. We only want sines in our final answer. So this that I'm underlining in red, we can make that 1 minus 2 sine squared. 1 minus 2 sine squared x. Now this sine x, I'm going to switch back to black ink, leave it out here. That is going to need distributed at some point. So I'm just going to go across this and clean it up a little bit. We've got this 2 sine x. That's going to stay at 2 sine x. We've got a cos times a cos. Well, that's cos squared. We'll do something with that in a minute. And then plus, we've got this sine x times the quantity in parenthesis. I'm going to put the sine x first because that's just how I roll. And then we've got 1 minus 2 sine squared. Okay, at least now everything's down to just x. Our angles are just x's. So the key here now is to get everything just in terms of sines. We've got a cos that we've got to take care of. Actually, it's a cos squared, but we'll be all right. So, underlined in red, cos squared. We can replace that. Let me just copy this 2 sine x. Cos squared is 1 minus sine squared. That's not even any of our new formulas. That's just a good old Pythagorean triple. Sine squared plus cos squared is 1, so cos squared is 1 minus sine squared. And now, that's a good point. Why don't we distribute here? So this sine x is going to distribute to the 1, so that's going to be a plus sine x. And we'll distribute the sine to this sine squared, so now it's a minus 2 sine cubed. That's supposed to be a 3 sine cubed x. All right. Okay, one more distribution back over here on the left. We're going to distribute 2 sine x to the 1. So that's going to be a 2 sine x. Minus, distributed here, minus 2 sine cubed. Minus 2 sine cubed x. And then I'll just copy the blue stuff. It's good to go. Plus a sine x minus a 2 sine cubed x. All right. Let's combine up our terms. And I'm going to put the positive one first. So we've got a 2 sine x and another sine x. That makes 3 of them. 3 sine x. And then we've got a minus 2 sine cubed and another minus 2 sine cubed. So that's minus 4 of them. Minus 4 sine cubed x. And there is a triple angle formula, everything in terms of just sine x. Now I know usually you write in descending order. Of course, it's perfectly acceptable to put the negative 4 sine cubed first, and then a plus 3 sine x. But a lot of math books, since it's 2 terms and one's positive and one's negative, they'll usually put the positive one first, even if the negative one is of a higher power. So we did that for the sine of the triple. In the huddle, you're going to do the same thing for the cos of the triple, and you're going to set everything in terms of cos x. Now, before you pause the video and try this on your own, this is going to start just like the last one did. The cos of the triple angle can be rewritten as the cos of 2x plus 1x. So flip back in your notes, you're going to use the cos of a sum to break that apart, and then start looking for opportunities to use Pythagoreans and your new double angle formulas. So try that out, and I'll see you after you unpause the video. Okay, we've got the cos of a sum. Cos of a sum. So that pattern is cos, cos minus sine, sine. Cos, cos minus sine, sine. Now remember, our end game here is everything just in terms of coses. And we put in our angles. 2x goes first, x goes next, 2x, and an x. All right. So let's start. I'm going to use green ink and just underline our double angles. There's a cos of 2x, that's a double, and a sine of 2x, that's also a double. We're going to replace those with something right now. And again, we want coses in our answer. So for the cos of the double, we might want to use option 2. That's going to be 2 cos squared minus 1. 2 cos squared minus 1. And that's still multiplied by this cos x. We will distribute that at some point. Now, sine of the double, well, there's only one thing we can replace that with. Sine of 2x replaced with 2 sine x times cos x. And then we've got times another sine x. So to save from rewriting this all again, I'm going to multiply this sine by the other, and now this is a sine squared. Okay, so again, everything's going to be in cos when we're done. And I see lots of coses now. There's only one thing giving us trouble, and I'm going to underline it in red. This sine squared. So we're going to replace that with something, but first let's go over here and distribute. This cos is going to hit this and become a 2 cos cubed x minus, distribute the cos to the 1, now it's a minus cos x, minus 2 times, I'm going to replace sine squared with 1 minus cos squared. And we're also going to multiply that by this cos. Let me switch to blue ink so it sort of stands out. Cos x. Okay, now this is going to be interesting. Let me just copy this first part. 2 cos cubed minus cos x. Notice kind of the way I wrote this, we're going to distribute a negative 2 and also distribute the blue cos. So this 1 is going to get hit with the negative 2 and become a negative 2, and then get hit by the cos, and now it's a negative 2 cos x. This negative 2 is going to hit that and turn to a plus 2 cos squared, and then that's going to get hit by another cos, so now it's cos cubed. Cos cubed x. All right, let's combine terms. 2 cos cubed and another cos cubed. We've got 4 of those. 4 cos cubed of x. And then we've got a minus 1 cos and then minus 2 more of them. So that's a total of minus 3 cos of x. So there is our very own triple angle formula, rewriting cos of the triple down to just everything in terms of coses. Excellent. And that is enough for this video. Here is the assignment. It is on WebAssign, at least I did it last year. These would be the problems that are on WebAssign. If you're having any computer issues, these would be the problems to do out of the book. When we are in class together, I've got some odd problems here picked out, 7 and 9. And then these here, we'll check those out for practice in class. I'll see you in the day 2 video.